any question about that international was only was addition is relatively easy to solve. And any question that only was multiplication is relatively easy to solve.
So we should maybe step back for a little bit and just talk about prime numbers.
Okay.
So they're often referred to as the atoms of mathematics. Can you just speak to the structure that these atoms provide?
So the natural numbers have two basic operations attached to them: addition and multiplication. So if you want to generate the natural numbers, you can do one of two things. You can just start with 1 and add 1 to itself over and over again, and that generates you the natural numbers. So additively, they're very easy to generate: 1, 2, 3, 4, 5. Or you can take the prime number. If you want to generate multiplicatively, you can take all the prime numbers, 2, 3, 5, 7, and multiply them all together. And together, that gives you all the natural numbers, except maybe for 1. So there are these two separate ways of thinking about the natural numbers from an additive point of view and a multiplicative point of view. And separately, they're not so bad. So like any question about that natural numbers that only was addition is relatively easy to solve. And any question that only was multiplication is relatively easy to solve. But what has been frustrating is that you combine the two together, and suddenly you get this extremely rich. I mean, we know that there are statements in number theory that are actually as undecidable. But even the simplest problems that combine something multiplicative, such as the primes, with something additive, such as shifting by 2, separately we understand both of them well. But if you ask, when you shift the prime by 2, how often can you get another prime? It's been amazingly hard to relate the two.